Next on Web Dev Ladder, why would Svelte 5 change what we love about the framework? Well, it turns out there are many reasons. Today, we're going to look at a couple of problems related to its inconsistent and glitchy reactivity. First, let's hear what Svelte creator Rich Harris has to say about the new version compared to the old.
I'm very excited about Svelte 5. I think it gets rid of a lot of the pain points of Svelte 3 and 4. And I don't want to be too negative about Svelte 3 and 4 because like a lot of people use them and they love them.
People seem to like it, yeah.
They do seem to like it, but it's...
and they're wrong. No.
Yes, it's actually really kind of frustrating to see people talking about Svelte 3 and 4 when we know that Svelte 5 is going to be so much better, and like, we're just like, I almost don't want to recommend that people use Svelte until we bring out Svelte 5. Because,
stop using it.
I know it's difficult. So we got a lot of things right with Svelte 3, but there are some things that candidly we didn't get right.
But there are some things that candidly we didn't get right. Whatever could he mean? Svelte is very well liked in the surveys. Well, as one of those wrong people who really love Svelte, after using it for 5 years, I can kind of see where he's coming from. In this video, we're going to take a look at the details around two systems of reactivity in Svelte 3, reactive statements and derived stores. And then we'll see how Svelte 5 signals fix those problems. So you may have seen some social media posts either joking or complaining that Svelte 5 is now React, but I cannot overstate how superficial of an observation this is. Svelte 5 is not React, it's Solid. Solid, if you haven't heard of it, looks like React and uses JSX, but Svelte and Solid are much closer cousins than the functionally pure React. Svelte 5 changes its reactivity system to use signals, and Solid and its creator, Ryan Carniato, deserve a lot of credit for popularizing signals. Let's listen to Ryan describe a problem he calls consistency.
Consistent means like if you have state, the derived state, and the result of the effect should be the same at all points. If you're completely consistent, these should be the same, which they are in Solid and they are in React. In Vue, and I think Svelte 5, you're going to see that internally, like the derived value and the state are the same, but the effect is deferred, right? So it's like internally consistent, but externally, there's a lag. But in current Svelte, you can update state and then read from the derived value and it's not updated. So I could say that is not consistent.
Ryan is describing the behavior of reactive statements in Svelte 3, those lines of code that start with $:. To repeat, when the dependencies change of a reactive statement and you read that value synchronously, you're going to get the old value. That's usually not what you want. What he's saying does not apply to derived stores, but those have their own unique problem that I'll describe in a moment. He elaborates more.
When you defer the effects, you're internally consistent because your reactive graph is consistent, but your outputs are not. And when you defer the notification, you just aren't consistent at all, because you can like write to a signal and read it, and then read and compute it and get the old value. This is why people have issues with old Svelte. This is kind of broken feeling.
Kind of broken feeling. I think that's fair. We're going to slow down and see exactly what he's talking about, and also take a look at the problems with derived stores that Svelte 5 signals also solve. So I created this Svelte 5 REPL, which you can find a link in the description. And there's also a blog post if you prefer to read. What we're going to do in this REPL is swap uppercase and lowercase first names and last names. You can see these A's are the first name and the B's are the last name. And the very first thing to notice here is that the DOM looks consistent. And actually when we swap, you'll just notice the DOM looks fine. So you might be like, oh, look, there's no problems. Why are we doing Svelte 5 at all? And that's kind of the point. The details can be very gnarly. So this is actually simpler than it might appear, but I'm going to walk through the details so we can see exactly what's happening here. There's a lot of machinery around the actual computations that allow us to see and inspect what's going on under the hood. So this is way more complicated in terms of this implementation than what we're actually testing. You can see right here, we have this $:AB equals. This is that reactive statement that Ryan described as being inconsistent. And we'll see that in just a moment. But the actual calculation here is just this. You can just kind of ignore the fact that that's even there. Same with the derived stores. We have a derived store using derived, and we are also logging in this. This could have been a one-liner. It's more verbose than the other two forms, but it still could have been a one-liner. Again, we just need to do more stuff because we're doing this logging when we're doing those calculations. And then finally, runes. We can see we have something very similar. We have derived by. It would have actually just been $derived A plus B, just like that. But again, you don't need the dot by. It's just $derived. But in this case, we did because we needed to have, we snuck in a side effect, which you're not supposed to do, but it's totally fine in this case. So what we're interested in is the log statements differences between these three forms. So what's happening is these three different components are being mounted, and then we do a whole bunch of calculations and log stuff to the DOM. And so every time we see swap, what's happening is and I'm not going to click the button just because I don't want to have to get into more log statements, but the idea is it's going to go from uppercase to lowercase, as we saw before. So every time you see swap, we're swapping the case of those variables. And so our full name will go on every swap from either lowercase to uppercase or vice versa. So let's look at our reactive statements first and see what might be the problem. So you can see here that we're swapping immediately. That's what we're swapping right here on initialization, swap before first read. And then we actually do our first read, which is right here. And so you can see our first read is undefined. And you can already see that that first read is different for both derived stores and derived runes. We actually have the correct expected first read. We started with lowercase, we swap, and then we go to log, and we expect to see uppercase because we swapped the value. But this is that inconsistency problem that Ryan described. So let's look at the second swap that happens still during component initialization. We're saying swap after first read. And so here we have that swap after first read log statement. Then again, this time we're actually logging. For reasons that I won't get into, I had to say, don't read that value on that first swap. It's because when you read values, you get derived calculations sometimes appearing. So that's why this is a little bit different between the first swap and the second swap. So in this after first read swap, what we see is we still see these two undefined values. This is the initial value of the $AB. This is like the AB variable. Initial value is undefined. And then the value you can see still after two swaps is still undefined. This is confusing to people when they hit it. We then see a set timeout, and we read the value. And there we finally see the value that we have been swapping. Remember, we started lowercase, we swapped the first time, that goes to uppercase. We swapped a second time, goes back to lowercase, and then our timeout and then logging, we're back to the lowercase. So that's what we expect. And you can see at the bottom here for all of them, we end at lowercase. So for derived stores, you might see that, oh, look, we are getting the values we expect. Sort of. There's a very insidious problem here with derived stores. What's happening, you might notice there's one extra log line. What is that log line? Well, it's it's this one. And that should be sending off alarm bells. If we are in our data, we're pretending that lowercase values for first name and last name are consistent and should be together. So when we swap them together right here, we're saying A equals to uppercase, B equals to uppercase, one after the other. So when we do that, though, with derived stores, you can see it's the exact same logic here. When we do this with derived stores, the problem is the derived stores are eagerly recalculating. So our log statements, when we're going to derive here, when it's deriving the value, you can see it's actually computing A with lowercase, which is the first thing we swapped, and then it's going to our final value, with full lowercase, where B goes to lowercase. And this is known as glitching in reactive programming. This is often totally not a problem. You don't even have to think about it much of the time. But when it bites you, it can really bite you. Because what this means is if you have a subscriber, say if you did subscribe like this to that derived store, you might send off API calls with data that makes no sense. You might also, for other reasons in your business logic, have calculations that create derived values that are corrupt or make no sense, and that causes problems elsewhere in your app. So the idea is that we can totally avoid this problem with both reactive statements and, as we see, with runes. You'll see here, in no case are we logging uppercase and lowercases mixed together like we do right here. So we can see two different problems here, right? We see the inconsistency of reactive statements, and we see the glitching of derived stores. I'm going to go ahead and now swap, and we can see now everything went to uppercase here. And starting at this right here, we can see what happens. So we updated to lowercase, we started lowercase. We're going to swap, and notice again, this is that problem. After the swap, we're still lowercase. And then after a tick, we get the value deriving yet again. So that's over here. That's being logged right here. And that's because we're rendering in the DOM here. But notice, this is a problem. This is that inconsistency problem. Before we swap, right, we're saying right here, this is where we say before swap, we're lowercase, right? And then after swap, we're still lowercase. That's inconsistency, and that's very confusing, and it can cause all sorts of weird problems. With derived stores, things kind of just work, right? So it looks pretty good, except again, we have glitching, right? This calculation right here. So in both cases, every time we hit update, we are getting, I'll do it one more time so we go to lowercase. Every time we're updating, we see some problem with one of these two cases. In the case of reactive statements, we see right here this inconsistency where it looks like it hasn't changed from here to here. And then in the case of derived stores, we have this glitching state, which can sometimes just ruin your day. These glitchy values are also wasteful. Theoretically, this computation didn't have to happen, and the fact that it did means that we could have significant impact downstream by recomputing stuff when we're just about to invalidate that computation. So we've seen how with reactive statements, we have inconsistency problems. Before the swap and after the swap are the same, meaning you can't synchronously read derived values. When it comes to stores and signals, we can before the swap and after the swap, we see the new value in both cases, before the swap, after the swap. But then the problem with derived stores is that they glitch. So that's the summary of how these three systems look. Nothing is perfect. Engineering is always about trade-offs, and signals are not perfect. There's also choices that you might have opinions about. For example, with the deferred effects that Ryan describes, Svelte 5 signals implementation has some quirks that people will have to know how they work. However, eager effects would also have their own quirks. Let's hear what Ryan Carniato has to say about Svelte 5's choices.
I think this is still the best place to be. Or this. Basically anything but this. This is the worst one. So it's good that Svelte's getting rid of it. It's also kind of crazy when you think about the Svelte community being accepting of this for so long. Because this is probably the worst.
As someone who's used Svelte 3 full-time since its release in 2019, I can attest to what Rich and Ryan are saying. The situation before Signals was not great, and as we can see, it was full of confusing details across two different systems. But now, I think it's fair to say I'm flush with optimism about the future of Svelte and Signals more broadly. There's a proposal in TC39 to add Signals to the JS language, and most of the major frameworks, with React being a notable exception, being in a functional paradigm, have adopted Signals in 2024 or are in the process of adopting them. So Signals give us a consistent glitch-free and efficient reactivity model. And so far, I've really enjoyed working with them. Unless you think Ryan Carniato is biased against Svelte, listen to what he has to say about Svelte 5.
I'm talking pure technology here, and Svelte 5 is an absolute game changer. Some people might have dismissed Svelte prematurely because of the language stuff. Come back and look at Svelte 5. Honestly, like, it is, they've addressed a lot of the stuff. Absolute game changer.
See you next time.